So in this question, just 10% of the students got all 3 marks that are available here. Can you get all the marks here? So the question is basically asking us about a negatively charged rod. It's telling us that this rod is held near an earthed conductor. Okay, so I'll underline the key points. Explain why a spark jumps between the negatively charged rod and the earthed conductor. Okay, so it's asking about the spark here. And so what key points would you mention to get all 3 marks here? How do you explain this sparking phenomenon in a structured way to get you the 3 marks and to show all your knowledge and make sure that you actually get this exam question completely right? So go ahead, have a go, and let's see what you guys would write. So in this video, we're going to be going through some of the common mistakes that students make when they do electricity questions. And this question is a really good example of that. And so this question is testing our understanding of why we get sparks and what happens when you have a big buildup of electricity or electrical charge in one particular area. So in this case, we have a rod, remember, and we've got loads of basically electrons on this rod. That's what it's told us because we have a buildup of this negative charge. And so what happens when we bring this rod close to an earthed conductor? Okay, so it's testing what happens when you have this buildup of charge in one particular area. And immediately when you think of this buildup of charge, you should be thinking of static electricity. And so a lot of students, they make the mistake where they don't understand the static electricity topic well enough. And in particular, in the static electricity topic, you have electric fields, which you need to understand, and also how these relate to sparking as well. Okay, so let's go through this question and see if you guys fell into the same common mistakes and same pitfalls. Like I said, just 10% of students got this completely right. So let's see how to answer these questions. So like we said, what happens when electricity has this one buildup of charge? So like I said, what happens in static electricity where one part of your material has a buildup of charge and something else basically does not? So this big buildup of charge is basically going to create a really strong electric field around your rod. Okay, so over here, we've got our big buildup of charge, and that charge is actually the thing that's going to create the electric field. And that means that on the rod or very close to the rod, you're going to get a really high potential. Okay, so over here, basically, you can say that any point here is going to have a very high potential. And the key thing here is that because you're very close to the field here, essentially the field being generated by this charge itself, the closer you are to this field, the higher that potential is going to be. However, and remember, the potential is just a way to describe how much electrical energy there actually would be at a point. Okay, so it gives us an idea of how much electrical energy would be over here. The higher that the stronger that field is, the higher the potential would be. Okay, now we need to bring it into relation to this question. So in this question, we're told that we have actually a conductor over here. So this conductor, we're also told, is earthed. Now again, a common mistake here is students don't really understand what it means when we say we have an earthed conductor. So hopefully you guys are familiar with that term earthing. Well, earthing basically means that this conductor is connected to the earth, and so the earth itself can either take away the charge if it's needed or supply as much charge as is necessary to basically keep this conductor at 0 volts the whole time. Okay, so this means that this conductor always has a potential of 0 volts. Okay, so over here you've got a really high potential, and over here you have basically no potential, 0 volts. So immediately what you should be able to then make the link towards is that between these two, you have a very high potential difference. Okay, so over here we say we have a very high potential difference. Now this is quite important because when we think about the rod and the conductor, we can also think about it in a slightly different way. So if I just draw the rod like this, for example, so this is our rod. Remember, we have this buildup of electrons at one end of our rod. That's providing this big buildup of charge. And over here we have our conductor again, just like we had before. And the reason why I've just drawn it out again is because essentially what we want to be able to spot is that over here you're going to end up with this electric field because you have this potential difference. Okay, so there's going to be an electric field between our rod and our conductor. And because, like we said, we have this really strong potential difference or really high potential difference, this is going to directly lead to a really strong electric field. Okay. Now, why is that important? Well, the reason why that's important is you have to think about what is in between this conductor and the rod. Over here is just air, okay? So this air is usually going to be an insulator, right? And so the idea is because this air is usually an insulator, that means the electrons will never be able to travel between the rod and the conductor normally. Now, the exception to that is because you have this really strong electric field, this really strong electric field can actually end up ionizing this air. And what does ionizing mean? Well, essentially this means that it strips off some of the parts of the air molecules, and ultimately the important bit that we want to focus on is that when this air is ionized, this suddenly becomes a conductor, okay? Now again, why is that important? Well, just like we said, right, for the electrons to actually travel, they need to be traveling through a conductor. If there was just an insulator between the rod and the conductor, that would mean that the electrons would still be stuck on the rod. They would have no path to travel. Now, as soon as this air is a conductor, this is when you suddenly get this discharge of the electrons on the rod. So the electrons now, they started at our rod, and now they're going to jump over because now they can travel through this air because it's now a conductor, and they hit our earth conductor over here. Okay, so that is basically what happens, and this jumping of electrons over here, this is basically the sparking. Okay, and another way that you can write that is that basically the sparking is there's essentially a current through the air. Okay, so the key point is the electrons jump from the rod to the conductor because there's a surplus of electrons on the rod. Remember, because we know that that's the case because the rod, it told us in the question, is negatively charged. So if you see over here, remember, it's negatively charged. That means there's a surplus of electrons, and so therefore the electrons are going to jump from the rod onto the earth conductor. And once they're on the earth conductor, of course, they basically travel through to the earth to essentially maintain that 0 volts potential on the conductor there. Okay, so that is the full explanation. Now obviously this question is only worth 3 marks, so you don't need to say all of that for 3 marks. So what is the summary, that the minimum you can say? So essentially what you do need to mention is that there's going to be a large potential difference between the two objects. This point over here, that's a large potential difference between the two objects. You also need to mention that the charge or the electrons move through the air. And essentially you need to mention that they go from the rod to the conductor. So that's kind of the minimum. You can see you can say very little to actually get the 3 marks, but it is obviously important that you guys understand what is actually happening here and why this phenomenon occurs. Okay, so a very common mistake where students don't really understand this very well, and when the question comes up, they can ask you lots of different things about it. It's unlikely they'll ask you a question where they want you to go into as much detail as we just did there, but if you understand all the different parts of it, then any question they ask you about sparking, you should be comfortable in answering it. And if you understand obviously these terms of what is earthing, what does it mean when you have a conductor versus an insulator, and what actually happens when you have this buildup of charge, and how do electric fields come into it, then you'll be able to explain any question like that. Okay? Okay, so this next question is testing your knowledge about transformers. So just 15% of students got all 4 marks on offer over here. And so let's take a look. It seems like it's pretty tricky if only 15% of students got all of the marks. So essentially what we're given over here is a diagram of the national grid, and we need to explain what transformer X is doing in enough detail to get all 4 marks. So what would you say for this question to get all 4 marks? How would you structure your answer to make sure you get 100% of the marks available? So the common mistake here that students make is they don't go into enough detail when they answer this question. So it's 4 marks, so you need to write enough to make sure you get the 4 marks. Technically, students, if you ask them what the transformer X is doing over here, they might be able to tell you, but will they be able to tell you in enough detail for this exam style question? So when we answer any kind of exam question, we should be looking at the marks available and thinking how to structure our answer. Now it says explain why transformer X is used in the national grid. It's not as simple as just giving 4 reasons why transformer X is used in the national grid. There's not 4 reasons. It's about giving the reasons that you know of and explaining them in a way to get the other marks. Okay, so let's break this down. So the first step basically is to identify what kind of transformer this actually is, right? So if you notice in the question, they didn't actually tell you what this transformer is, and they specifically labeled it as transformer X. Now, if you can see from our transformer, it's deliberately between the power station, immediately after the power station, and before the overhead transmission cables. So you should, hopefully everyone should be able to identify that this is what we call a step-up transformer. And straight away, if you identify that it's a step-up transformer and you explain what that actually is, well, a step-up transformer is something that steps up the voltage, okay? So if you say that, then this straight away is worth your first mark, okay? Because you notice that this is not actually stated anywhere in the question. So using this, or identifying this, will give you that first mark. So fundamentally, we say here that the step-up transformer increases the voltage, or even better if you call this the potential difference, as they do in the exam questions. And basically then you need to explain what is the point of actually increasing that potential difference. Remember, explain why transformer X is used in the national grid. Well, we know what transformer X does, but why do we want it to do to increase the voltage? Well, the key thing actually here is that transformer X, it does increase the voltage, but when it increases the voltage, what also ends up happening is it decreases the current. And so immediately when you say that, again, you get another mark just to say that it decreases the current. But you need to make that next link there is why are we actually interested in decreasing the current? What is the effect that happens when you decrease the current? Well, when you decrease the current, what actually happens is you end up reducing the energy loss, or particularly the energy loss due to thermal energy into the surroundings, okay? So this is kind of the key point that should have come up in your revision. The whole reason that we have these step-up transformers is to decrease the current, and the whole reason of doing that is you want to decrease the thermal energy loss, okay? So the lower you have that current, the less heat is generated when the electricity is traveling along any kind of cable like that. And so that's kind of the last link that you want to make, right? So you can see hopefully the 3 marks that we got. So what's the 4th mark for? Well, the 4th mark is basically you want to put this into context. Remember, in the question is specifically mentioned the national grid. So what's special about the national grid that we want to decrease the thermal energy that we lose to the surroundings? Well, the idea here is that when you decrease this thermal energy that's lost to the surroundings, you end up increasing the efficiency. And you can just say here the efficiency of the national grid itself, or particularly you can say the efficiency of energy transmission through those cables, if you want to be even more specific, and an even better answer there. Okay, so that's basically what you want to write, and that's the final mark, is basically bringing it back to the question. And you can see here the reason really was just this point over here, right? So when we said why is transformer X used, well, that's the reason, but you need to build it up and explain fully essentially how transformer X is used to get to this stage, and then what is the actual point of using it in the national grid. So you're using all the different parts of the question to actually shape and structure your answer. So hopefully nothing in that question was actually new to you. It's just a case of being able to structure your answer properly to get all the marks and show off all your knowledge and explain things to the degree that the exam question wants. So these next few questions, I don't actually have any stats for you on how students did, because actually these questions were discounted on the paper that they were on. Now, that doesn't mean there's anything wrong with these questions. It's just to do with the fact that these were published in COVID time papers, and back then there was some advanced information and they got some of that advanced information wrong. And so basically they discounted these questions. But we can still use these, as it does show a lot of common themes of where students went wrong and questions where students might find it a bit challenging. This was the last question in the paper, and those two tend to be a little bit harder. So this question is showing a circuit, and the question is basically, why would this not turn on? So we can see we have a circuit for hair straighteners over here. Why does it not turn on when only switch S2 is closed? So it's only 1 mark, so go ahead. What do you think you would say for 1 mark? So the mistake here is students basically need to understand what conditions are required for electricity to actually flow. And fundamentally, there's 2 main things that you need for electricity to flow. The first thing is that you need a source of potential difference. And the second thing is that you need a closed loop or a closed circuit. Okay, so you need to be able to have a complete circuit. So when we close switch S2, technically now we do have a closed loop. This is now a closed loop. But as you can see, in this closed loop, you don't actually have a source of potential difference. The source of potential difference is up here. This is the power supply, okay? So essentially, what you would need to do is to have the circuit include this power supply, either by closing S1 or maybe moving the power supply down there. And basically, when you answer this question, why do the hair straighteners not turn on when only switch S2 is closed? For 1 mark, you could basically just say, well, you need to either close S1 to complete the circuit and include the power supply, or you could say that there's basically a gap in the circuit, which again is kind of the same idea. In principle, you're saying that the whole circuit needs to be at least this bit, okay, where you include the power supply in that. Okay, so for 1 mark, that's what you would have to say. Okay, so moving on to the second part of this question. So now we're given figure 14, and it says it shows a hair straighteners with switch S1 closed. So you can see now S1 has been closed, just like we suggested before. And this time, however, switch S2 and S3 are open in this configuration. Then we're told switch S2 and S3 are then closed at the same time. Explain what happens to the power output of the power supply. And it's 3 marks. So again, I'll just pause here, just from the question here, the way we answered the first part. Can you think what we need for this second part? What would you say for 3 marks? Okay, so the key fact about this question is it touches on parallel circuits, and that is a topic that a lot of students do tend to struggle with. So we're asking what happens to the power output, okay, the power output of the power supply when we close these switches. So you need to understand what you need to say to get these 3 marks. How are you going to structure your answer? So the mistake a lot of students make here is failing to understand what exactly is the impact when you close these switches. And essentially, hopefully, we recognize that when we close these switches, what we're doing is we're adding on branches to our circuit. And that basically means we're going from a series circuit to a parallel circuit. Okay, now that fact alone is not going to be enough to answer these questions or to get these marks here, but you need to use the fact that you're going from series to parallel and understand what the impact of that is, which a lot of students don't do, to basically answer this question: what happens to the power output of the power supply? Okay, so just like we said, we're going from a series circuit to a parallel circuit by adding more branches. And so the impact here, the key thing is when you add more branches, what is actually impacted? It is the resistance, okay? So the first thing that you can say to get the first mark is what happens to the total resistance of the circuit, okay? So again, we're not looking at any specific resistor or resistance in any specific branch. We're looking at the total resistance of the whole circuit. What can you say about the whole circuit when you add branches? Well, hopefully you should know when you go from a series circuit to a parallel circuit, or you add more branches to an existing parallel circuit, what you're doing is you're decreasing the total resistance of the circuit. And you do need to be able to explain that qualitatively, not necessarily quantitatively. So what does that mean? Well, that means that basically they're not going to ask you to do a calculation here to show what happens to the power output, but you need to be able to explain what happens to the power output by being able to explain what happens when you add more branches or you go from a series circuit to a parallel circuit. So just like we said, the resistance decreases. And why is that? Well, in a series circuit, if we just had this top part, this top loop, the current would have one path to go down. And when we add more branches, basically we're giving the current extra opportunities and extra branches to flow down. And so when we think about resistance, the way we want to think about it is how difficult is it for the electricity to flow. And when you add more branches and more paths for the electricity to flow through, you're basically making it easier. Okay, so that's the way we want to explain what happens to resistance when you have a parallel circuit. Okay, so just like we said, the resistance decreases, or the total resistance of the circuit decreases, and this is basically what you would say for your first mark. Okay, great. So that's the first mark, but it doesn't actually answer the question, because remember the question is asking about power output, so we need to be able to link the idea that the resistance is decreasing to the power output. So the first thing that we can basically write down is the simplest form of our power equation, and that is power equals IV, or P equals IV, where I is your current and V is your potential difference or your voltage. And so because we're interested in the power, we don't have resistance directly in this equation, but we can think about how the resistance being decreased would affect the current and would affect the voltage. So the first thing is, let's look at the potential difference. So again, we're looking at the potential difference of the power supply. So in this case, what we're trying to say is that when you have a parallel circuit, what happens to the potential difference? Well, actually, for a parallel circuit, you should know that the power supply, let's call this 5 volts. If this was 5 volts, then you would have 5 volts through this branch, you would have 5 volts through this branch, and you would have 5 volts through this branch. So the potential difference in a parallel circuit is the same throughout all the branches, and it should be equal to the potential difference of the power supply, okay? So what we can basically conclude here is that this voltage stays the same, okay? It's going to stay the same. Or you can say it stays constant as well. So in that case, if we know that the voltage stays constant, then really we can narrow down our power equation, and we can say that the power in this case is just going to be dependent on whatever happens to the current, okay? If the voltage is constant, then we're just interested in the current. So now we need to be able to explain what is the effect on the current when we decrease the resistance. And again, the easiest way I think to do this is to think about an equation with voltage and current and resistance, and hopefully everyone is thinking about V equals IR, or Ohm's law, okay? So here, very simply, we want to understand what happens to the current, so we rearrange Ohm's law for I, so I equals V divided by R, and immediately we can make the same kind of conclusion. So over here, we said, well, the voltage stays the same, so therefore over here, this V is going to be constant. So we're just interested in what happens when we decrease the resistance, remember, because we've gone to a parallel circuit. So we know the resistance decreased. So when you have a smaller R, well, essentially you're dividing by a smaller number, and therefore that is going to give you a larger current, okay? The answer over here is going to be larger when you divide by a smaller number, okay? That's just mathematics, so hopefully that makes sense. And therefore we can see that the current has actually increased while the voltage has stayed the same. So when we look at our power equation again, P equals IV, you can tell that if we increase the current and the voltage stayed the same, that means we did also increase the power output. Okay, so not the R, but the power output P. And so essentially, just to break it down in terms of where you get the marks here, well, the first thing you want to say is that the resistance decreases. And because the resistance decreases, you can explain that the current increases. And because the current increases, you can explain that the power output increases. Okay, so really simple to actually get the 3 marks as long as you understand what you're talking about. You don't need to put it into too much detail, but obviously to actually understand what happens to the power output, you need to work through the separate steps. Okay. So a few key takeaways from this question then. The first one is that essentially you need to be able to break a circuit question down like this into the separate calculations, the separate parts of it. You really need to understand the difference between series and parallel circuits, and what happens when we add branches or take away branches or move from a series circuit to a parallel circuit. And lastly, we do need to understand what happens when we increase or decrease resistance. As you can see, there was a couple steps here to actually work out what happens to the power. So you need to be able to work through those steps just like that. Okay. So those are just a few of the most common mistakes students make in electricity questions. We only looked at one paper, so there's plenty more questions that you can go through and practice with in the different papers. So if that was at all useful, then feel free to leave a like on the video. Subscribe if you want more of these type of videos. We do also have a video on the channel going through the whole electricity topic. So if you guys were confused about anything we came up with here, then please do go through that as a first kind of port of call. And yeah, hopefully that was useful, and I'll see you guys in the next one.